बिस्मिल्लाहिर्रहमानिर्रहीम। अज़ीज़ तलबा व तलबात, कल आपने पढ़ा था कि न्यूक्लिक एसिड्स क्या होते हैं, क्या क्या इनके फंक्शंस होते हैं और कौन से इसके कंपोनेंट होते हैं। न्यूक्लियोटाइड्स और न्यूक्लियोसाइड्स क्या होते हैं और न्यूक्लियोटाइड और न्यूक्लियोसाइड फिर किन किन चीज़ों से मिलके बनते हैं। शुगर से मिलके बनते हैं, फॉस्फेट या फास्फोरिक एसिड से मिलके बनते हैं, और एरोमेटिक अमीन जो है वो नाइट्रोजन अमीन्स से मिलके बनते हैं, पायरिमिडीन्स हों या प्यूरीन्स हों। ये आपने लास्ट टाइम पढ़ा था। आज हम जो देख रहे हैं टॉपिक वो है प्राइमरी स्ट्रक्चर, द कोवलेंट बैकबोन। प्राइमरी स्ट्रक्चर जो है वो जब आपने स्ट्रक्चर ऑफ मॉलिक्यूल को पढ़ा था, जब आप उसके बारे में पढ़ते थे तो वहाँ पे स्ट्रक्चर ऑफ मॉलिक्यूल की हम बात ये करते थे कि स्ट्रक्चर ऑफ मॉलिक्यूल से क्या मुराद है। कनेक्टिविटी ऑफ द एटम इन ए मॉलिक्यूल and the bond order which is present between the atoms of the molecule is called as the structure of the molecule. Here also connectivity of the atoms connectivity of the atoms, and especially connectivity of the atoms of the aromatic amine with that of the sugar or ribose or carbohydrate part, and third is the phosphoric acid which is present in the form of phosphate ion. Arrangement of these three which are repeated again and again and forms the structure. So connectivity of the aromatic amine, which atom of the aromatic amine is connected with the, this is here aromatic amine part, which is called as thymine, and it is the pyrimidine base. Now it is connected with the carbohydrate or sugar part, which is called as deoxy ribose. Since here H is present at 2 position, H is present, so it is deoxy ribose. Which nitrogen atom of the thymine or pyrimidine base is connected with which atom of the D-ribose? Which atom of the D-ribose is connected with the phosphate ion? And phosphorylated, this is phosphorylated end, and this is, here you can see 5 prime and R5 dash end from this side, and this is 1 unit, and then a next unit is present here. This is rather this is one component, this is another component, this is another component, this is phosphodiester. Phosphodiester is connecting the two deoxyribose units with one another. So more properly you can say that this will be the repeating unit, this one. This whole will be the repeating unit. Now the structure will be the connectivity of the pyrimidine or thymine base with the deoxy ribose sugar or carbohydrate, how it is connected with the phosphate ion. Then this ribose, deoxy ribose, is also connected with the an ester with the phosphate ion another, and this phosphate ion is connected with another the ribose sugar. So this is diester. Here this O is connected with this one CH2, this O is connected with this carbon, so it is a phosphodiester. So this is the connectivity of the aromatic amine with the deoxy ribose, and the connectivity of the deoxy ribose with the phosphate ion, and then also with another diphosphate ester. And this diphosphate ester is how it is connected with the another deoxy ribose sugar. This is called as the structure. And in the primary structure, the covalent backbone is present. Here you can see DNA can be classified into three different types of the DNA. Three different types of the DNA. One is called as capital A DNA. Capital A DNA. Second type is called as capital B, B for ball, capital B DNA. And third type of the DNA is called as Z DNA. Z DNA. Now, the most commonly found DNA is called as bDNA. B for ball, bDNA. bDNA. And the difference between bDNA and aDNA is of the thickness. aDNA is thicker than that of bDNA, and bDNA is thinner than that of aDNA. This is the major difference between the aDNA and bDNA. And there is also difference. Second difference is the base to base distance. Base in one strand and the base in the another strand, and the base in another strand. This you can see here, this one, this distance, the distance between this is adenine, this is thymine, adenine and thymine, and this is GC, guanine and cytosine. This distance between the two bases which are present in the two strands or two threads of the DNA are different. In ADNA, the distance between these two bases in two strands of the helix is 290 pm. 290 pm. 290 pm. While in that of the bDNA, bDNA, it is around about 340 pm, picometer. So here in the main differences, you can see main difference between ADNA and bDNA is ADNA is thicker as compared to bDNA, and its two diameter, you can say diameter between the two strands, this is less in case of the bDNA, and it is more in case of ADNA. This is the major difference between ADNA and bDNA. What is the difference between zDNA and bDNA? In the zDNA, there is left-handed helical structure, while in case of A and bDNA, these are right-handed helical structure. So here you can see this is the this is clockwise. This is clockwise. You can see helical structure is formed this strand. This is clockwise. So right-handed, clockwise or right-handed. ADNA and bDNA has a right-handed helical structure, while that of zDNA has left-handed helical structure. What is helix? HELIX, helix. हेलिक्स अगर हम क्या करें, एक तार लें और उसको एक सिलेंडर लें और उस सिलेंडर के इर्द गिर्द उसको रैप करें, उसको बांधें, उसके इर्द गिर्द, एक सिलेंडर के इर्द गिर्द उसको लिपेटें तार को, तो कैसी स्ट्रक्चर बनेगी? इस तरह की बनेगी। ये सिलेंडर है दरमियान में, फिर नीचे से सिलेंडर, फिर नीचे सिलेंडर के ऊपर से ये इस तरह की स्ट्रक्चर बनती है। ये कब? जब आप एक तार लेके एक सिलेंडर के ऊपर उसको स्पाइरल फॉर्म में क्या करें, रैप करें, स्पाइरल फॉर्म में उसको लिपेटें, ठीक है। तो इस तरह की स्ट्रक्चर आपके पास आती है। ये तो ये जो होगी सिंगल हेलिकल स्ट्रक्चर होगी। और फिर आप क्या लें, दो वायर्स लें, दो तारें लें और उनको एक को इस तरह पहले सिलेंडर के ऊपर लपेटें پھر دوسری کو اپوزٹ سائڈ سے اس طرح کر کے یہ سلنڈر کے اوپر لپیٹیں. تو جو سٹرکچر آپ کے پاس آتی ہے اس کو ڈبل ہیلیکل سٹرکچر کہتے ہیں. ایک ہی تار لے کے سلنڈر کے ارد گرد اسپائرل فارم میں اس کو لپیٹیں اور پھر سلنڈر کو بیچ میں سے آپ موو کر کے نکال دیں. تو اس کی جو شیپ بنے گی وہ کیا ہوگی؟ وہ ہیلیکس ہوگی یا ہیلیکل سٹرکچر بنے گی، اور پھر یہ سنگل ہیلیکل سٹرکچر کہلائے گی. اور اگر آپ دو تاریں لیں اور ایک ہی سلنڈر کے ارد گرد اس کو اسپائرل فارم میں ریپ کریں، ان کو لپیٹیں، تو پھر درمیان میں سے سلنڈر کو آپ موو کر کے ہٹا لیں، تو جو سٹرکچر بنے گی وہ کیا کہلائے گی؟ وہ ڈبل ہیلیکل سٹرکچر کہلائے گی. تو یہ ڈبل ہیلیکل سٹرکچر بنتی ہے. تو ڈی این اے از اے ڈبل ہیلیکل سٹرکچر. اچھا، ہم بات یہ کر رہے تھے کہ یہ 3 ٹائپس کے ڈی این اے ہوتے ہیں: اے ڈی این اے، بی ڈی این اے اور زیڈ ڈی این اے. اے جو ہے وہ تھکر ہوتا ہے ایز کمپیئر ٹو بی، اور بی جو ہے وہ تھنر ہوتا ہے ایز کمپیئر ٹو اے. ان میں تو یہی ڈفرینس ہے. باقی یہ ہے کہ دونوں جو ہیں وہ رائٹ ہینڈیڈ ہیلیکل سٹرکچر بناتے ہیں. اور جو زیڈ ہے وہ ان دونوں سے کیسے ڈفرینٹ ہے کہ وہ لیفٹ ہینڈیڈ ہیلیکل سٹرکچر بناتا ہے. تو یہ میجر ان میں ڈفرینسز ہیں جس سے آپ ان کو آئیڈینٹیفائی کر سکتے ہیں. سب سے زیادہ جو کامن ہوتا ہے وہ ہے بی ڈی این اے، which is بی ڈی این اے. اب بی ڈی این اے جو ہے وہ اس کی شیپ کو کس نے ایکسپلین کیا ہے؟ اس کی شیپ کو واٹسن اینڈ کرک نے ایکسپلین کیا ہے. واٹسن اینڈ کرک. لیکن ہیلیکل سٹرکچر پہ جانے سے پہلے آپ دیکھیں بیک بون کو ہم تھوڑا سا ڈسکرائب کرتے ہیں جو اس میں موجود ہوتی ہے. بیک بون کیا ہوتا ہے؟ سیریز آف ورٹیبریز. انسان کی ریڑھ ہڈی میں کیا ہوتی ہیں؟ ورٹیبریز ہوتی ہیں جو پوری بیک میں موجود ہوتی ہیں. ورٹیبریز جو ہے کنیکٹ ہوتی ہیں اور سکل سے لے کے پیلوس تک وہ جاتی ہیں، اور یہ کیا بناتی ہیں؟ اسپائن بناتی ہیں. اور اس کا کام کیا ہوتا ہے؟ اٹ از دی چیف سپورٹ آف اے سسٹم. اگر یہ جو ہے وہ بیک بون نہ ہو تو پھر کیا ہو سکتا ہے؟ اس میں یہ دل کو بھی سپورٹ کرتی، دل کے اوپر وزن نہیں آتا. پھیپھڑوں کو سپورٹ کرتی ہے کہ یہ پریس نہیں ہوتے اس طرح. اور کیا ہوتا ہے؟ کڈنیز کو جو ہے وہ پراپر فنکشن کرنے دیتی ہے، وہ پریس ہو کے ان کی نالیاں جو ہے وہ ان میں رکاوٹ نہیں آتی. لیور کو کام کرنے دیتی ہے. تو کیا ہے؟ وائٹل جتنے آرگنز بھی ہیں ان کو وائٹل سپورٹ مہیا کرتی ہے کام کرنے کے لیے. تو چیف سپورٹ آف اے سسٹم، اس کو ہم جب کہتے ہیں کہ یہ کوئی چیز کسی سسٹم کی بیک بون ہے تو اس کا مطلب ہے کہ یہ سب سے امپورٹنٹ سپورٹ جو اس چیز کو چلانے کے لیے ہے وہ یہی ہے. اچھا، ہم بات کر رہے تھے کہ کس کی یہ جو سٹرکچر ہے یہ کس کی ہے؟ یہ ہم بیک بون کی دیکھ رہے ہیں. تو بیک بون میں کون کون سی کنیکٹیوٹی ہوتی ہے؟ یہ دیکھیں، اس کو ہم کہتے ہیں بیٹا این گلائکوسیڈک بانڈ. بیٹا این glycosidic bond is present between the thymine, which is a pyrimidine base, and deoxy ribose, and which carbon atom? 1, 2, 1. C1 and N1. C1 N1 glycosidic beta N bond. Beta N-glycosidic bond is present. Beta is mean it is directed in the upward direction. If it is directed downward, that will be alpha. The hydrogen is here, hydrogen is at alpha, and this is directed in the upward, so it is beta. So it is beta N-glycosidic bond between the carbon number 1 of the deoxy ribose and N1 of the pyrimidine base or the thymine base. And this is number 1, 2 and 3 prime or 3 dash. Why here prime or dash is used? This is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash or 5 prime. Because in the pyrimidine bases we are using the number 1, 2, 3, 4, 5, 6. So to differentiate between the numbering of the pyrimidine base or thymine base and that of the deoxy ribose, here we use the prime or the dash, 1 dash, 2 dash, 3 dash or 3 prime. At 3 prime, what is present? Phosphodiester is present. One ester is connected with the one deoxyribose molecule. Another ester is connected with the 5 prime or 5 dash of the another ribose. 3 prime or 3 dash of one and 5 prime or 5 dash of another deoxy ribose. So 2 deoxy ribose molecules are connected with phosphodiester. What is present here at 5 prime position of the deoxy ribose, here phosphoric acid in the form of phosphate ion is present here. So here this is the backbone of the Bdna or DNA. Ribose is connected with the phosphodiester, then it is with the deoxy ribose, then it will be connected with another phosphodiester, and then with the ribose through the covalent bonds. Now the bond between deoxy ribose and pyrimidine bases is C1N1 beta N glycosidic bond, and the linkage between the ribose and phosphate ion is 5 prime, C5 prime O of the phosphate. At 3 position, C of the deoxy ribose and O of the phosphate are connected with one another. So heterocyclic bases along with the pentose phosphodiester make the backbone. What the primary structure of DNA means the order of heterocyclic bases along with the pentose or ribose sugar and phosphodiester it makes the backbone. So this is called as primary structure, in which the aromatic amine bases are connected with the pentoses or pentose, and the pentose is connected with another pentose by phosphodiester linkage. This makes the backbone or the primary structure of the DNA. And the most common form of the DNA is bDNA. Now there are present specific groupings of the pyrimidine in one strand and that of the another strand, or in one thread of the helix and another thread of the helix. A is always connected with the T of another strand. G of one strand of the DNA helix is always connected with the C of another strand. These are called as complementary bases, AT and GC. AT, A in one strand, adenosine is present, thymine is present in another strand of the here. This is what thymine is connected with adenine, and cytosine is connected with guanine. Cytosine is connected with guanine. How they are connected? Here you can see this is the thymine, this one. Thymine, this is adenine. This structure is of adenine, this structure is of thymine. So AT or TA, these two are complementary bases. If thymine is present in one strand, it will be connected with the adenine in another strand of the DNA helix. So these two are called as complementary, COMPLEMENTER, complementary bases. So it is called as TA. If thymine is present, it will be connected with adenine. If adenine is present, it will be connected with thymine. How they are connected with one another? Through, here you can see this is one hydrogen and this is nitrogen. Lone pair of electrons are present on nitrogen. These are connected with one another by hydrogen bond. Here NH bond is present, it is connected with the lone pair of electron of oxygen. So two hydrogen bonds are present between AT or TA complementary bases, due to which two helix or two helix strands, two helix threads, two helix ribbons are held together. Similarly, another complementary base pair is cytosine is connected with guanine. Cytosine is connected with guanine. This is the structure of the cytosine. This is structure of guanine. Or GC. Guanine is connected with the cytosine. Cytosine is connected with guanine. Through how many hydrogen bond? One hydrogen bond between NH of this and oxygen, lone pair of oxygen, this one. Second hydrogen bond is between NH bond of this and lone pair of nitrogen, this one. Third hydrogen bond is present between NH of the this bond and C double bond, lone pair of electron of oxygen of C double bond O in this bond. Three hydrogen bonds are present between what? Between GC complementary bases. GC complementary bases are strongly held as compared to AT or TA complementary bases, since 2 hydrogen bonds are present in the AT and 3 hydrogen bonds are present in GC. Now, Watson and Crick postulated that purine and pyrimidine bases project inward towards the axis of helix. This is the axis of helix. This line is axis of helix. So bases are projected inward here towards the axis. From this helix, these are directed downward towards the inward and downward towards the axis of, this is the axis of helix, and here bases are directed in upward in the inward toward the axis of helix. Now, according to this model, the dimensions of adenine-thymine base pair are almost identical to the dimensions of the guanine and cytosine base pair. So, their thickness is consistent with the core thickness of DNA strand. Thus, if the purine base in one strand is adenine, then its complement COMPLEME and its complement here, its then its complement in the antiparallel strand must be thymine. This one. So this is AT. Adenine is connected with thymine. Similarly, purine in one strand is guanine, and its complement base is the cytosine, which is pyrimidine base in another strand. So in this way, these are connected with one another. Now, keep it in your mind that in the DNA are present. How? These are two strands are anti-parallel to one another. Two strands are anti-parallel to one another. Here you can see this is the simplified structure of the helical structure. What is this? This is the thymine base in one strand. Then another strand will have adenine, AT or TA. Then it is connected with the D-ribose. It is connected with the diphosphate ester. Diphosphate ester is connected with another deoxy ribose, and the base is directed inward, and it has adenine. Then it will have a thymine in the second strand, and here if it is cytosine, then it will have guanine in the second strand. So these two are complementary bases with one another. GC are connected with 3 hydrogen bond. These two are connected with 3 hydrogen bond. These two are connected with 2 hydrogen bond with one another. These two are connected with 2 hydrogen bonds with one another. So these are the complementary bases. Hydrogen bond can be shown here by dotted lines. Two dotted lines mean two hydrogen bonds are between Ta or thymine and adenine bases, and adenine and thymine bases. Two hydrogen bonds are present. Three hydrogen bonds are present between the GC or Ca, guanine and cytosine. This is a very important thing which you should remember. And another thing is here this one. If this is the simplified arrangement of what? The bases in one strand of the helix. This is another strand of the helix. One strand of the helix runs from 5' to 3'. Its antiparallel will run from 5' to 3'. If this is considered as 5 to 3 direction, this is from 5 to 3'. It is antiparallel to that of this one. Here you can see this is adenine. In one, its complementary base in the second strand will be thymine. Here thymine is present, its complementary base will be adenine. Here cytosine is present, its complementary base will be guanine. Here cytosine is present, its complementary base will be guanine. Here adenine, its complementary base is thymine. Here guanine, its complementary base is cytosine. Here thymine, its complementary base is adenine. Here cytosine base, its complementary base in the second strand will be guanine. Here adenine is base in one strand, thymine will be its complementary base. So these two strands run antiparallel to one another. One is running from 5' to 3'. Second runs from 5' to 3' in this way. Here 5' to 3' in the right word, and here 3' to 5' in the right word. These two strands are representing the bases of the bases which are present in the two strands of the double helix structure. Now I think you will be able to understand the primary helical structure of the DNA. Now here you can see we are going to describe what is this. This is the double helical structure of bDNA. B, capital B, B for ball, DNA. So to account for the periodicity observed from the X-ray data, if X-ray data is taken of the DNA, there is present a periodicity in the DNA data which shows that possible base pairs are stacked one on the top of the other with how much distance? The distance between the two base pair is 340 pm picometer or 0.34 nanometer. This is distance between the two bases in two strands of the helical structure. This is one very important characteristic between the bDNA. One very first thing we have already discussed, that bases are directed inward towards the axis of the helix. Second point is the distance between the two base pair is 340. This one, 340 nanometer. This base is present in one strand of the helical structure. This base is present in another strand of helical structure. Now here you can see the distance is 340 picometer between the two bases, between the TA, thymine and adenine, are between any two bases of the two helical strands of the DNA. Second important characteristic is that 10 base pairs are present in one complete turn of the helix. 10 base pairs are present. 10 base pairs are present. Since here one base pair is not written here, so you can start from here. This is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is this one is one complete turn of the helix, and it has how many base pairs? 10. 10 base pairs are present in one complete turn of the helix. Another very important point is that one turn has the length how much? 3400 picometer. This is one turn has the length of 3400 picometer, and in the picometer minor groove 12 two type of the grooves are present. This is minor groove, which has width of 1200 picometer. This is major groove. This is the groove. This is major groove. It has the length 2200 picometer. 2200 picometer is of the long groove, and our major groove and minor groove is of 1200 picometer. Total is 3400 picometer in one complete turn of the helix. In what? In beta DNA. Now in the double helix structure of the beta DNA is most common. Now in the what happens this is in the bDNA. Now in the double helix, the bases in each pair are not directly opposite one another across the diameter of the helix. They are slightly displaced. So due to which sugar phosphate backbone leads to two different size grooves. Two different size groove. One is major groove, another is minor groove. Each groove runs along the length of the cylindrical column of the double helix. On the other hand, on another form of the secondary structure are known. Other forms of the DNA of the secondary structure are known. They differ in the distance between the base pairs, the number of base pair per turn of the helix, and one of the another type of the DNA is ADNA. ADNA is also right-handed helix. ADNA is thicker than BDNA. और रिपीट यूनिट कितना है इसका 2900 pm, जबकि रिपीट यूनिट 1 कंप्लीट टर्न उसका कितना बनता था, वो 3400 पिकोमीटर है बीटा डीएनए में, और एडीएनए में कितने हैं 2900. और उसी तरह क्या है, देयर आर 10 बेस पेयर्स पर टर्न ऑफ द हेलिक्स, और इसमें जो दो बेसिस में जो वक्फा है डिफरेंस है वो कितने हैं 290 पिकोमीटर बिटवीन द बेस पेयर्स, और बीटा डीएनए में कितना था 340 pm और पिकोमीटर. So this was about the structure of the primary structure of the DNA. Different types of the DNA, primary structures of the DNA. Primary structures of the DNA, it is of the helical structures. So I think you will be able to understand what is the double helical structure and what are the types of the DNA, ADNA, BDNA and zDNA. Inshallah, next time we will discuss the tertiary structure or supercoiled DNA. Okay then.